So thank you everyone for being here. When IBM told me about this event and the Cognitive Colloquium, it sounded like a visit to the future. And so I couldn't resist, but we're here now to talk about exactly what that future looks like and what's important to know about it. So I'm very pleased to talk to you about this. I guess of all the applications that we just saw of this potential technology, which of these gets you the most excited?
For me, I'd say everything. Healthcare, the healthcare challenges that exist obviously here and around the world, getting healthcare costs under control, having more effective treatment modalities, having a results-oriented approach, but also being able to propagate what we learn globally to strengthen that worldwide. As an educator, as a president of a university, the application of these sorts of systems in education is thrilling. And then, if I have a chance to talk about it, I'm very focused on what I call intersecting vulnerabilities with cascading consequences and how one can use cognitive systems and collaborative decision-making to address those kinds of things.
Can you elaborate a little bit on that last point?
Sure. If you look at the great Sendai earthquake of 2011 that destroyed the Fukushima Daiichi nuclear power plant, it not only caused extensive damage and radiation release to the plant and from the plant, but there was a lot of infrastructure destroyed, as well as global consequence because of the interruption of certain key manufacturing capabilities in Japan, not to mention the displacement of thousands of people and the loss of life. And so when one thinks about that and thinks then about the design of nuclear plants and associated infrastructure on a go-forward basis, the ability to bring in historical insights, current data, and to look for where there can be anomalies or triggers is very important. As you know, I used to be the chairman of the Nuclear Regulatory Commission, so that one is on my mind.
Mm-hmm. Dr. Kelly?
Well, I would agree with President Jackson. These are all just incredibly exciting areas, and every time I think about that, Heidi, or I answer it, I see something the next day that excites me even more. As an example, some of the recent results that the team has gotten in studying neuroscience and neurological diseases is very exciting. And what this is all about is studying mental health problems. You know, it's often said, well, the eyes, are the window to the mind. Actually, the way we speak is another tremendous window to the mind. And a fantastic team who's here today has been working on using Watson to not only understand what we're saying, but how we're saying it and the patterns. And it turns out that you can find early signs of schizophrenia, Parkinson's disease, and other neurological diseases just in the patterns of our speech. So early detection of neurological diseases. And then on the flip side of that, if we can really understand how the human mind learns versus these systems, I think it might be possible, and we've challenged ourselves, could we actually accelerate learning? Could we not just learn more, but learn faster? Because we're starting to understand through the great work in neuroscience how and when the brain learns, how and when neurons, synapses are formed. And if we can intercept at those points in time with the individual way a person is learning and impedance match that with the system, then I think we're going to see great things. So today, that's my most exciting thing. Tomorrow, there's going to be another one.
And so how did you decide on this lab as a way to solve those problems? How did it come about?
Well, I'll give my version. John gave a lot of background, and with the phenomenal work that IBM had been doing with cognitive systems and this amazing platform we have here and work here in artificial intelligence and cognitive computing, he and I actually hatched this plot. about a year and a half ago at a dinner. You know, I had John to dinner at the president's house. It's always, you know, you have to watch out what happens when you come. But John had his own plot, so then I'll let him take up from there.
Well, we, as I mentioned, have had a tremendous partnership with Rensselaer here. And we knew that something special was going on in this human-system interaction. And, you know, kudos to President Jackson. Back in the early 2000s, she decided to commit to build this experimental performing arts center, which at the time, President Jackson, you remember, some people said, why are you building a performing arts center at one of the world's best technological universities? But it was really this intersection at that time of performing arts and technology, but that's just another form of human system interaction. And that never left my mind. And then as we started to think about, well, where are there really smart people, great students, and where is there something at this scale where we can do group immersion? And you know, with the amount of data, again, we need different ways to visualize and interact with that data. Frankly, it was an easy choice because there's no place else like this in the world. So here we are.
Yeah, Impact opened in 2008, and we've always talked about what would happen at the intersection of media, arts, science, and technology. And by technology, we meant immersive digital technologies. And this is both a performance center and a research center. And each of its venues is its own laboratory. It also, because of that, allows multi-sensory, multimodal inputs and the ability to tailor environments in unique ways. And so with the advent of cognitive systems and the partnership with IBM, it allows us to marry these very unique technologies in ways that we think will play across the fruited plain that we've talked about.
I think there's something very interesting about that for all of the digital promise, we still need to see something or feel it or experience it for it to really be real to us, to understand it. And I guess that kind of leads into what I'm next curious about, which is, you know, we see algorithms all around us. I see it as a journalist in the Google search algorithm and how Facebook serves up things on my news feed, and even in how we measure traffic at Mashable. But why has it taken so long for something like this to get started, for AI to take off in general?
That's a great question. So, I mean, AI goes back to at least the 50s, late 40s. And again, I think a lot of people experimented with different technologies in AI. And I wouldn't say failed miserably, but it was enough that we were in an AI winter for decades. But I think it was before its time. And what changed and what led to the Watson system in 2011 is that there was a convergence of a number of factors. First of all, enough data was digitized to make a difference. That, you know, if you could build a system, there was now enough digitized information that you could do something meaningful. The second thing was that computing power now became sufficient to break through the barrier. And I mean, people will never know how close those humans were to beating Watson that day. I mean, we literally took the latest, highest performance Unix system off our production line, loaded Watson on it to beat those humans. So it was just a unique point in time. And I remember I introduced the Watson taping, and I said, look, I don't know what's going to happen today, but I can tell you it's just a matter of when, not if, this system will be able to do this. And it was that close. And then lastly, advances in neural networking and machine learning algorithms were now sufficient. So we had all three sort of come together at that point in time. Watson demonstrated to the world this could be done, and now everybody is applying some form of AI and algorithms to their systems.
But I would also add to that, and this builds off of the idea of neuromorphic computing and the like. I'd say two other things. One has to do with imbuing computational systems with actual reasoning capabilities, because that is key, and that is a key part of making inferences and so forth. Being able to bring certain of the social sciences in as part of that to make the systems more intelligent and human-like. The computational power of high-performance computing that allows one to build, very sophisticated models that play into these kinds of systems. And then advances in things like machine vision, the ability to begin to to bring multimodal and multisensory inputs into these cognitive systems. So all of these things, and the ability to access data in unique ways, bringing data off of the web, having capabilities in the cloud. So this is a unique moment where all these things are coming together. But it's a question of how we use them.
Right. Now, one of the things that also surrounds these efforts in general is that not everyone in society is convinced that the future is going to be better than the past, right? And so there's a considerable amount of fear, not just from dystopian movies that we've all seen, like Gattaca and I, Robot and all of that paint the rise of the robots as problematic, but even in the academic and business literature, the FT Business Book of the Year, as of last night, is Rise of the Robots, How a Technological Future is Going to Take Away Our Jobs. So there's clearly a lot of fear there. I do want to note for the record that Dr. Kelly has assured me that Watson will not take away my job. That was my takeaway from dinner last night, so I just want to get that on record if it comes up in the future. But nonetheless, creating something that is that close to sentient but not sentient is a very fine line. And how do you think about that? And how do you think about telling other people about that in such a way that it doesn't compound the fear?
Well, I think if one looks back over history, each time there's been an advance in a technology, people have always worried about it taking control or spinning out of control. Let me use a couple of examples. Think about having a mechanical conveyance that hurtles you down a road at 60 to 100 miles an hour. People would have great fear about that, or one that flies you through the air and it does not, kind of looks like a bird, but not quite. I mentioned nuclear power earlier, and you can, and there have been accidents, not many, that are really significant. The real point is that anytime one uses anything other than one's bare hands, one is using a technology of the day, whether it's a pencil, a calculator, a PDA device, supercomputer. So technology is as people use technology. People think of technology as technology is as technology does. But that's not the right way to think about it. It's how we use technology. And so technology always sits on a knife edge, but it's up to us to use it for the kinds of purposes we talk about. And that's why we build into our education of our students discussions about ethics in the development and use of technology. And so that we understand that, and we have what are called HAS, Humanities, Arts, and Social Sciences inquiry courses that are structured to challenge our students to think about that. And then finally on the job loss, because that is always a big deal. The kind of thing that John and I do, and there's an interesting parallel in our backgrounds in that he did a physics bachelor's and master's and a doctorate in materials engineering. I did a physics bachelor's and a physics PhD, but I did a bachelor's degree, a bachelor's thesis in physics, in materials science and engineering, even as a physics major. So one migrates, and what we really need to do is to educate our students to be intellectually agile. And even as technologies change, they change the nature of work and what the jobs are. Mm-hmm. And so the challenge is how we keep people abreast. But we have the opportunity to use these very technologies to educate our young people in a different way. and for the jobs of the future.
I would absolutely agree. But by the way, I was incredibly impressed with your students and their questions yesterday. I mean, not just the technical depth. I was glad I didn't have to answer the questions, but it was very clear their awareness and how they were wrestling with these issues and body and mind and the implications. So you're doing a lot of great things here.
Well, we get great students here. They're wonderful.
I think it is back to this human end system. And the pattern we've seen, Heidi, across every industry is that humans at every task, there's sort of a normal distribution in terms of ability. People who are exceptional, people who are in the mean, and people who are still struggling to learn something. And whether it's in medicine, in finance, insurance, the call centers, what we have seen consistently is that if you introduce this technology properly, the very best become even better at it. The nominal of the distribution, the norm, becomes as good as the best. And the people who have been struggling to learn, when they have this supplemental, become very good and can do higher level jobs. And we've seen this consistently across every industry. So again, I know people are worried about man versus machine, but I think it's this synergistic effect, and we're seeing human beings be even better every place we apply this technology and be able to do new things. So I think it's about where do we insert it in the process of human tasks.
And we see it in the Mandarin Project with language acquisition with our students. And we haven't fully deployed cognitive systems in that. We're just beginning to do that, but we already understand that the pedagogical approach we've taken that has to do with gamification and immersion and the early introduction of cognitive agents accelerates and strengthens the learning.
Mm-hmm. Well, I'm interested in something that you mentioned, and you answered a little bit of what I was curious about in terms of how this changes our workforce, right? I mean, you're saying that it gives them different tools, it makes them more effective. And in that, let's call it dichotomy between man and machine, I know you don't believe that it's oppositional, right? I mean, that's not what you're doing. You're creating something to augment human intelligence. But there are people like Bill Gates and Elon Musk and so on who have said we should think about the rise of machines, not because of the machines, but because of how humans will program them. And so I'm very interested in how you go about talking to your students. You mentioned those classes in Haas, and how you talk to your scientists about how they should be approaching these problems.
Well, again, the real point has to do with technology is what our intent is and how we choose to use it. So as we educate the students who not only will use these technologies, but who will develop them and or evolve them, it is very important that a key part of their education is focused on, the responsible use of technology. Now, can we make every person an angel? No. But can we challenge them and expose them to what the consequences can be? But it's all part of how we help them to grow, because it's the same thing we learn relative to the consequences of any decision making we make. It's just that there's a lot of power in their hands. And we find that our students here are very focused on wanting to make a positive difference and really applying the capabilities they have to solve global challenges. And that's where we try to keep them focused and to offer them opportunities in that way. But they come to us with that kind of focus.
And I would say that it continues right into the workforce and the IBM people who are creating these systems. They're very conscious of the strengths and weaknesses of these systems. And as an example, in healthcare, we always want a medical doctor between the patient and the system. Watson will come up with tremendous recommendations for treatments and therapies and whatnot based on massive amounts of data without bias. But it also has, a number of, I'll call it blind spots. It doesn't consider quality of life factors. So Watson may recommend a certain chemotherapy cocktail, but that may not be appropriate for that individual based on where they are in their life cycle or how they want to live, their life at this point in time. And so our researchers are very conscious of how do we introduce these technologies into the workflow, and if it's in a critical situation, keep a human being in the loop or in front of the loop when those key decisions are being made. And that's a pervasive sort of culture in the company.
I have a few more questions, but I'm sure you do too. If you have questions, start lining up at the microphones on either side. You'll see them up front here, and we'd love to answer them. So I guess my question is, you talked a little bit about the industries where it could be useful. What industries have embraced this the most, in your opinion, so far?
Well, from our experience thus far, it is literally every industry has reached out to us. Yeah, we're sold out, if you will. I need more students, President Jackson. We'll hire everyone you can graduate from here. Every industry. The one that first embraced it was healthcare. And what I found interesting is the healthcare industry and medical doctors have not always been the first adopters of new, at least IT technology. This one, though, completely shifted them out of their comfort zone. When they saw what Watson did back in 2011, they were coming to us in large numbers. This is going to change healthcare. And it was not only the ability to handle massive amounts of unstructured technical journals, medical publications, their own notes, which aren't easy to read, but they concluded, they knew where it was going. They knew that the data was exploding beyond what they could do. And they saw this as such a leap forward that this was something that they had to embrace. And so oncologists around the United States jumped on board here very, very quickly. And so healthcare, I'd say, is probably the one that's been the first and the most aggressive because of the explosion in the data. But we're literally seeing it in every industry. And of course, the next big one that I'm very interested in is bringing Watson to bear in cybersecurity and in security. And that's obviously, given current events, a major area of interest.
And in fact, there are great opportunities, and they are being recognized in everything from intelligence to energy to looking at climate change and climate effects and how we access and use natural resources and environmental stewardship broadly. And so I think these are some major coming trends. And I think there are great opportunities in the financial services sector. We have a globally interconnected, financial system. I think those things, there are lots of anomalies that occur. And I think the ability to understand when something might be developing or when explaining something that has occurred. So these are great opportunities, but I agree with John that healthcare seems to have really taken hold.
Yeah. I still have more questions, but I can see by the enthusiastic line there that we should throw it to the audience.
My question is about Watson. You keep referring to Watson in the singular, and Watson's kept evolving, and people keep pushing it to change. So it's probably a big family now. There's one of them right across from where my office is in Tech Park. Is it going in many directions? If two Watsons met each other, would they say, have I met you before? Have I seen your face? Because they must be evolving.
That's a great question. So are Watsons like aspens connected at the root, basically?
Well, let me say, I'll make one comment. Yes. They will meet here. That's what CISL will do. But
yeah, so you're absolutely right, Tim. The first Watson was a machine. Right. And then there were a couple of more, but not many, one of which is physically here. But soon after that, we took the brains, if you will, out of that system and moved it to the cloud. Why did we do that? Because that gave us scale globally. So literally with the flip of a switch, we can access Watson any place on the planet instantaneously. The second thing we did, as you indicate, is at the time, Watson was a natural language processing engine one thing with about 5 deep engines underneath it. Now Watson is 26 engines that are services on the cloud that you can access or compose on a global platform. So it's no longer one thing. In fact, it's not even several things. It's multiple services on the cloud. And then overlaying that is we have discovered that because the data is so important that there are industry-specific Watsons. So I don't know if a healthcare Watson ever met a cybersecurity Watson, whether they would know each other, but they are different instances based on the underlying data in the cloud.
Thank you.
Thanks, Tim.
A lot of times when you convert unstructured data to actionable information, questions about privacy come up. But I don't really want to go there. I want to go kind of beyond that with what might be a more provocative question. Cognition is part of the human condition, and the human condition also involves trying to recognize or assert good and evil or moral decisions. To what extent do you see this kind of cognitive effort having to build in a moral code interpreter? And how would you structure that? And how would you kind of put an override on the use of that data? Or do you even see that as being necessary?
Well, I'll begin and then President Jackson can comment. We are studying putting what we call policy engines inside of Watson. In a sense, override or instilling some of our own values into the system. We're having raging debates on whether that's the right thing or the wrong thing to do because you're immediately introducing human biases into the system. At the current time, our preference is to let the system run purely statistical and always use humans in the final decision process. But there are ways to introduce those kinds of human values into the system. But again, once you start to do that, Watson is sort of no longer Watson.
I showed the aborted film of the robot and with the self-awareness. So in our artificial intelligence and reasoning laboratory, there is a lot of work that's gone on having to do with self-awareness, reasoning, values. And then with our network science and technology center, there is work having to do with understanding hierarchy, power, cultural nuance, trust, distrust. But these are still at a very research level. But in point of fact, that kind of work is going on and will go on here and other places, not to displace, the imposition of human values, but to understand how they come into group decision-making.
It's interesting, too, to wrap together the first question and the second. It's interesting how different Watsons in different countries, perhaps, would interpret those moral questions differently.
That's correct.
That's a very good question. So we now have Watson in 7 different languages around the world, and it's not a translation engine on the back end of an English system. Watson actually parses and understands the language. So it, in a sense, is learning through the language, some of the dynamics in that society. So it's learning Arabic now. It's learned, French, Portuguese. So it is through the language learning essentially how we think.
That's interesting. It ties into studies showing that the language you speak can actually change how you think.
That's right.
That's interesting.
I'm not sure, maybe my question is related to the previous gentleman's. It does concern the moral aspects and perhaps enhancing human judgments. So would a cognitive system be applicable to a criminal justice system?
I think it is applicable to criminal justice. Again, not in the final decision of a judge or an arbiter, but in bringing instantaneously all case law forward in the judgment, all facts around the case, everything known about that particular situation Because in a sense, the decisions today are made only based on what's presented through a whole bunch of filtering processes. So I could see, again, Watson being an informer to a decision maker, not making the final decision, but making sure that all the facts are brought forward in an unbiased way.
Well, let me give an answer. Sitting here with a journalist, I'm going to jump off the cliff.
This
I
is
don't
being
know.
broadcast also.
I know. But if you remember, Rolling Stone having to retract an article that had been written about sexual assault at the University of Virginia. Human bias, points of view will always come into play. But if you actually have a cognitive system that not only can access and amass huge amounts of data, but can look for anomalies in the data and ultimately bring in information, not just that is already embedded in the system, but that it can draw in real time from other sources, as well as from a myriad of sources, can be part of, and that's what the CISL is about, group decision-making. And now you have editors, reporters, senior people, more junior people, videographers, and you have all of this data that also comes in multi-modes. One would like to think that, not that it removes bias, but it forces the issue of taking a broader perspective and a broader set of inputs before something gets committed to writing. And so that's an example, where we think it's very important.
We have an analogy to that actively right now in the healthcare industry, and this has to do, again, in the area of cancer and oncology. If, God forbid, you have cancer and you're going to go under chemotherapy, that specific cocktail is discussed at a cancer review board, a treatment. A number of physicians will get together, discuss the options, and make a decision or approve an option. Those people bring a lot of knowledge, but also a lot of bias, and they will openly admit they are short of information in making that decision. And they could make a much, much better decision with Watson bringing that information to the table. And we're also working on dialogue such that Watson can take part in the discussion. So if they say, well, we think we ought to do that, Watson can say, well, that's a logical answer, but did you know this? Did you know this person has this particular genomic mutation? That may not be the right answer for this individual. So again, left to the Cancer Review Board, but better unbiased information brought to the table.
Sir?
I want to take a little bit of a step away from some of the intellectual cognitive things that you're talking about and talk about connectivity and what it means in terms of where we are with basically low-speed fiber and needing to get to something that is more fiber optic, higher speeds in order to do and provide the platform for collaboration. That's my question.
I'll let you.
Well, it's a great question because the interconnect speed is now the bottleneck in all of this. And it's not a compute problem. The data is growing faster than we can transport it, even through the biggest fiber optic channels, particularly when you get into some of the advanced science and decision making. You cannot ship the seismic data, even if you could legally do it. It's so large, you cannot ship it between continents in any reasonable amount of time, even with the biggest light pipes under the ocean. So the result of that is that more and more compute is occurring where the data is. So in a sense, we're not moving massive amounts of data around anymore. We're moving the compute and the intelligence, the Watsons of the world, to the data so we don't have to move it. It just takes too long, not to mention the energy and the cost of moving it.
Right, and then the new data that has to be moved really becomes the insights that have come out of that.
Right. That's exactly right.
Compute where the data is.
Send the insight, not the data.
Right.
That's fascinating. I complained about my iCloud storage. I had no idea. We'll keep ping-ponging. We'll take this side of the room and then this side. Go ahead.
I think she was.
Oh, okay. Go ahead.
I want to go back a little bit to the idea of decision-making, particularly in innovation. And the example I've always thought about is Van Wagenen discovering tectonic plates in about 1925, and then being laughed out of the Royal Geophysical Society or whatever it was, because you had problems of bias, expectations, power, hierarchy, and being threatened. Now, as you start to build some of those human qualities, or at least understand them, into a Watson-like system, how do you balance that problem of innovation bubbling up from the bottom and being essentially laughable to the experts in the field?
Well, and it gets back to an earlier question, we were talking about putting certain human moral values in the system. One of the things we could do in Watson is to not just let it reach its own conclusion statistically, we could put in what we think is ground truth. And there's a raging debate in this whole area of cognitive computing, how much ground truth or human truth do we want to put into the system? We could get answers to certain questions much more quickly, but I believe that we start to introduce a lot of bias. Now, a lot of people get frustrated. They always point to the infamous Toronto question on the Jeopardy show, for anybody who saw it. It was a US city, how could it have answered Toronto? And the reason is that it only took the fact that it was looking for a US city as one factor in its conclusion. We didn't tell the system if it asked for a US something, it must be in the US, because we're starting to enter some bias into the system. So I personally think as long as we minimize that amount of ground truth or human bias, then it's going to be a powerful tool for exploration. The minute we start to introduce what we think we know, it's a slippery slope.
Interesting.
So Dr. Kelly talked about the power of human-computer collaborative systems, and Dr. Jackson talked about the role of universities in leading students to making good decisions in their life and applying what they've learned for good purposes. I'd like to sort of invite you to speculate a little bit about individualized cognitive systems, a system that's living in your phone and understands you very deeply and can advise you. And two applications that I thought about for this are helping to lead people towards short-term harmful economic decisions, like going to loan sharks, and in anti-corruption, leading people to recognize corrupting opportunities that they might not realize are corrupting, having dinner with the wrong person, accepting the wrong gift. Those are just two examples, but I'd like you perhaps to speculate about the power of having something intelligent and unbiased with you all the time as an individual.
I should also note that that's actually, that's quite a lot to think about, and it's the last question that we can take. But do feel free to continue talking about the questions afterwards. Dr. Kelly, do you want to answer?
Well, yeah, I'll begin. One area that's right in that zip code that we're particularly interested in is the aging population. I'm personally interested in this. But think about in your home environment as we age and our own cognitive capabilities start to decline. Think about a personalized cognitive system in your home that not only can assist you, but can actually measure your cognitive abilities based on your movements in the house, based on your speech patterns, based about short and long-term changes in behavior that might indicate a cognitive decline. So we have an effort that we're just starting around the whole aging population, which is going to be an enormous portion of the Earth's population. And that, we think, is a very, very interesting individualized use of cognitive capability.
You talked about avoiding having, quote unquote, dinner with the wrong person. It's an important thing. But in fact, one could imagine having a cognitive system that that has the facial recognition or some other, biometric that could potentially link to a database that might tell you that a certain individual is a rather unsavory character, and that would pop up and kind of tell you right away to stay away. You could imagine ultimately, but we are ways from this, where you have built-in sensor capabilities into a PDA type device that can have a built-in chemical sensor that can tell you if there's some danger, whether it's an actual danger having to do with undetected carbon monoxide or something that's even more sinister that might be the makeup of some weapon and can warn you away. So there are a number of possibilities, and you're right, those things can in fact be built into, we hope, the single device. But by doing, in fact, the multimodal work that we're talking about here, which by definition says that the inputs come from different sensory modes, it helps to advance the technologies to be able to do some of the kinds of things that you're talking about, as well as picking up on nuances of behavior and gestures.
It's a fascinating way to end. I want to thank you all for being a great, curious, engaged audience. And most of all, I'd like to thank Dr. Kelly and Dr. Jackson for their insights. Thank you so much.
And thank you.
Thank you, Heidi.
John, thank you. Heidi.